गुड मॉर्निंग स्टूडेंट्स, वेलकम बैक। अब हम नई एक्सरसाइज कंटिन्यू करेंगे।
Pause the video and see question number 1 from exercise 1.2.
Now we are solving this question. Question number 1. As you have seen the question, we have to prove it one function. Let x comma y belong to R naught such that fx equals to fy. Then fx equals to fy, and fx we know that it is 1 upon x, and fy we can write 1 upon y in that case. So if we reciprocal both sides, you will be getting x equal to y. So it is 1 function. As I have explained the function once again, that f such that r naught to r naught, and r naught is meaning set of all non-zero real numbers. Now on to, let y be an arbitrary element of R naught. Now this time we are talking about this as codomain, such that fx equals to y, then 1 upon x is equals to y, and x we can write 1 upon y, reciprocal both side. Clearly x equals to 1 upon y belongs to R naught. This time R naught is domain. For every y belong to R naught codomain, there exists x equals to 1 upon y belongs to R naught. This time domain, x belongs to domain. So fx equals to 1 upon x equals to y. So f such that R naught to R naught is onto. Hence f R naught to R naught is 1 onto function, as we have proved that is it 1 and onto function. So we have proved it. Now if we change R naught from the domain side to n, then what will happen? Part 2 of the question is that only. F such that n to R naught given fx equals to 1 upon x. For every xy belongs to n, we find that fx equals to fy. Fx we know 1 upon x and 1 upon y fy. So x is equals to y. So in that case again f is 1. But this is very important to understand. -1 and -2 will not have its pre-images, as you can see in this picture. N will have 1 2 3 infinite numbers, and this r will have infinite numbers, but this can be any real number. Like -1 will not have its pre-image here, because -1 reciprocal is -1, and -1 cannot be in this set. Similarly -2 reciprocal of this will be -1 upon 2. It cannot be here because it is set of natural number. So this function is not onto. Now we are doing question number 3. Prove that greatest integer function f such that r to r given by fx equals to square bracket x is neither 1 nor onto, where this square bracket x denotes the greatest integer less than or equal to x. We call it integer function, greatest integer function also, this one. Now see the solution. We know that fx equals to 0 for every x belongs to 0 to 1. Here 0 is included but 1 is not included. So f such that r to r is not 1. Why? Because 0 will mapped on 0, 0.1 will mapped on 1, 0 again, 0.2 is mapped on 0 again, and 0.9 is also mapped on 0. All the number between 0 to 1 including 0 will mapped on 0 only. So it is many one function, not one function. Also, f such that r to r does not attain non-integral values, so non-integral value will not have pre-image in the domain. As you can see here, again I have explained you one more kind of function, the same fx equal to 1 for every x belongs to 1 to 2. Here 1 is included, 2 is not included. It means 1, 1.1, 1.2, 1.999 will have its image on 1. But if I see 1.1, 1.2, 1.999 will not have their pre-image here in this R. So f cannot be onto. So f is not onto. Therefore, f such that r to r is not bijective function. It means not 1 onto. Now we are doing question number 9, which says f such that n to n be defined by fn equal to n plus 1 upon 2 if n is odd, n upon 2 if n is even, for all n belong to n. State whether the function is bijective. Justify your answer. This is very simple question. If you see, it is many one function because f1 will be 1 plus 1 upon 2 equal to 1 and f2 will be equal to 2 upon 2 is equals to 1. It means 1 will be mapped on 1 and 2 will also mapped on 1. It means this is many one function. Many one. Two elements have image on 1. So it is many one function. Now on to. Let n belong to n. This is set of natural number, this capital N, and this n is any natural number. If n is odd, natural number can be odd or even also. If n is odd, then 2n minus 1 is also an odd natural number such that f2n minus 1 equal to 2n minus 1 plus 1 upon 2. If you cut this 1 and 2 divide, then you will getting n only. If n is even natural number, then 2n is also an even natural number such that f2n is equals to 2n upon 2 equal to n if we cut 2 by itself. Thus, for every n belong to n, whether even or odd, there exists its pre-image in natural number, means n and n natural number. So f is a surjective function. Hence, f is a many one function. It is many one function. In this question, they told us to prove that it is bijective, but when it is many one, it is not bijective, because bijective means 1 and onto. It is many one, so it is not bijective. Now we are doing question number 10. Let a equal to r minus curly bracket 3 all the real number except 3. It means b equal to r all the real number except 1. Consider the function f a to b defined by fx equals to x minus 2 upon x minus 3. Is f 1 and onto? Justify your answer. Solution. See, I have written these sets once again, a and b, f a to b given by fx equals to x minus 2 upon x minus 3. Now, as we always do to prove 1 function, let two element from the domain A is the domain and B is the codomain, such that fx equals to fy. Fx we can write x minus 2 upon x minus 3, and fy we can write y minus 2 upon y minus 3. If you simplify this, you will be getting x equals to y. Just do cross multiplication and simplify, you will be getting x equals to y. It means f is 1 function. Now again, let y belong to B such that fx equals to y, and fx we know is x minus 2 upon x minus 3 as given in the question, equal to y, implies that x is equals to 3y minus 2 upon y minus 1. How we are getting this? X equals to 3y minus 2 upon y minus 1. I have explained you here. Just pause the video and you can check it easily. Clearly, x is equals to 3y minus 2 upon y minus 1 is a real number for every y does not belongs to 1. And y is an element from the domain, and in domain we don't have 1. In codomain, sorry. Fx equals to x minus 2 upon x minus 3, and if I replace the value x by 3y minus 2 upon y minus 1 as we were doing in previous questions, just after putting x as 3y minus 2 upon y minus 1, you'll be getting, after simplifying this, you'll be getting y again. You can check it easily. You can take LCM, and if you simplify this, you'll be getting y again. So f is onto, hence f is 1 onto function. It means it is a bijective function. In between, just pause the video and see those questions and try to solve it by yourself. अगर नहीं कर पा रहे हो तो हेल्प लेके देखना, ठीक है? थैंक यू.